I'll be taking you through this GCP Associate Cloud Engineer Practice Test. I have divided the questions into modules. So this is a module 1. Each module contains a set of 20 questions. So I will be taking you through all the questions and I will be explaining the solution for each of these questions. Now let's get started. Let's go through the first question. You work at a large credit card company that offers loans and credits to its customers. The company's app is hosted on GCP. There are 35 distributed backend microservices that your application requires. All the distributed microservices need to connect to a non-relational database using credentials. As a chief of DevSecOps, you want to make sure that the credentials are stored securely. Where should you store these credentials? The options are A. In the source code files, B. In an environment variable, C. In secret manager, D. In ACL's restricted config file. So let's take a look at option A in the source code files. Here A is incorrect because storing credentials in source code is not secure since it is easily discoverable in plain text by anyone who has access to the source code. So it's not secure to store your secret in the source code files. Next option is in an environment variable. This option is also incorrect because credentials will be available in plain text format and it is not secure. So anyone can view this environment variable. So it's not the secure way to store your secrets. Coming to option C, in a secret manager. This is the correct answer. Secret manager is a secure and convenient storage system for API keys, passwords, certificates, and any other sensitive data. So you can make use of secret manager to store your secrets. Option D is incorrect because access to the config files needs to be managed manually. This config file might contain the credentials in a plain text format which everyone can read. So this is also a risky thing to store these secrets in the config file. So the correct option will be the secret manager. So let's go to question 2. Your company extensively uses the Google Cloud platform for all its government related projects. The projects are distributed in a complex hierarchical structure with hundreds of folders and projects. Only the cloud governance team is allowed to view the full hierarchical structure. What minimum permission? Google recommended practices should be given to the governance team to perform their duties. So these are the options available. So let's take a look at each of these options. First option is not correct because we don't add users to roles of browser role directly, but instead we add users to a group and assign roles to the group. Whereas coming to option B, here also add the users to role, IAM role, viewer role. So we don't directly add the users to roles. According to Google's best practice, we usually don't add users to roles directly, but instead we add them to a group. And also IAM role, viewer role allows viewing IAM policies and not project hierarchy. So the second option is also not correct. Coming to option C, add the users to a group. Add this group to roles/browser. So this option is correct because it provides read access to browse the hierarchy for a project, including folder, organization, and IAM policy. So since the ask here is, we need to provide the minimum permission to the governance team. So this governance team wants to view the hierarchical structure of this project. So that minimum permission which we can give is option C. By assigning this permission to that team, we are providing a read access to browse the hierarchy for a project including the folder, organization and IAM policy. Last option is option D, which is also incorrect because roles IAM role, viewer role allows viewing IAM policy and not the project hierarchy. So the correct option is option C. Now let's move ahead with the third question. Your data science team uses Google Kubernetes engine for running their machine learning pipelines. These pipelines mostly train image processing models. Some of the long-running non-restartable jobs in a few pipelines require the use of GPU. How can you fulfill the request at an optimal cost? So these are the options. So let's take a look at each of these options. Let's take a look at option B. Add a vertical pod autoscaler to those workloads. Here option B is incorrect because vertical pod autoscaler does not work with GPU. Since in this question, some of the long-running non-restartable jobs in a few pipelines require the use of GPU, but making use of this vertical pod autoscaler does not fulfill this request. So the option B is incorrect. So let's check the option C. Here, add a node pool with preemptible VMs and GPUs attached to those VMs. Here, this option C is incorrect because preemptible VMs are not a good choice for long running on non restartable VMs. Option C does not work in this scenario because in the pipeline they have a long running and non restartable jobs. Option D, add a node pool of instances with GPUs and enable auto scaling on this node pool with a minimum size of 1. Here option D is also incorrect because adding a node pool of instances will obviously increase the cost for this scenario. So at the optimal cost, we can make use of option A, use the JKE's cluster node auto provisioning feature. Here, node auto provisioning is a mechanism of the cluster autoscaler which scales on a per node pool basis. With node auto provisioning enabled, the cluster autoscaler can extend node pools automatically based on the specification of the unschedulable pods. So we can make use of this option A. So in this scenario, option A is the correct one. Let's move on with the question 4. You're working at a startup that specializes in creating digital simulations of chemicals. You're working in a small team responsible for maintaining the uptime of 3 different projects A, B, and C. You want to monitor the CPU, memory, and disk of these projects in a single dashboard. What should you do? So let's take a look at each of these options. Here option A, sharing charts from different projects is not efficient and safe. Option B is incorrect because we are assigning the metrics reader role to projects A, B, and C. So this is incorrect because the metrics will reside in different projects and it will be difficult to show them in a single dashboard. Next, moving to the option C, use default dashboards to view all projects in sequence. This is incorrect because monitoring each project separately will be tedious and it is not scalable. So this option is not correct. While moving into option D, create a workspace under project A, then add projects B and C. So this is the most suitable one. Since workspaces are made for monitoring the multiple projects, we can make use of this option to create a workspace under project A and then add projects B and C. So we can monitor all of these projects in a single dashboard. So option D is the correct one. Let's move ahead with the question 5. Your app building company has several projects under its umbrella. Different teams at your enterprise have different cloud budgets, and the GCP billing is managed by different billing accounts. Your company has a centralized finance team that needs a single visual representation of all costs incurred. New cost data should be included in the reports as soon as it's available. What should you do? These are the options. Export the billing data to BigQuery using billing data export and create a data studio dashboard for visualization. By doing this, you can run an analysis on BigQuery after exporting the billing reports from all projects to the same dataset. So this is the correct option. Whereas option B is incorrect because CSV export is a manual process and it is not very efficient and a scalable process. Option C is incorrect because we need actual prices and not just estimates. So using pricing calculator, it just gives the estimates. But in our scenario, we need the actual prices. Moving to option D. Option D is incorrect because the reports view will not show billing information of all projects in the same window as the billing accounts will be different. So the correct answer is option A. Now let's move ahead with the question 6. You work as a cloud engineer at a social media app company. This app is using a hybrid cloud environment with some workloads on premises and some on GCP Compute Engine VMs. The on-premise network communicates with a GCP VPC using Cloud VPN over private IPs. A new internal service needs to be deployed on Compute Engine such that no traffic from the public internet can be routed to it. What should create such a VM? So these are the options available. So the correct answer is create the instance without a public IP address. Here the option A is correct because an instance without a public IP address is not accessible through the internet. So we need to create an instance without a public IP address. So in the question they have mentioned that no traffic from the public internet can be routed to it. So in this scenario we have to create an instance without a public IP address. So now let's take a look at the incorrect option. Option B, here create the instance with private Google access enabled. This is incorrect because enabling private Google access does not prevent internet traffic from entering the VM. Option C, Create a deny all egress firewall rule on the VPC network. This option is incorrect because we need an ingress rule in this case and not an egress rule. Option D. Route all traffic to the instance over the VPN tunnel by creating a route on GCP. This option is incorrect because it doesn't explicitly address the issue of preventing public internet traffic from reaching your instance. Now let's proceed with question 7. You are part of the infrastructure governance team at your digital ad agency. One of the apps is going through a revamp and requires changes in infrastructure as well. You need to get the proposed changes reviewed by your team. What is Google's recommended practice for it? So these are the options available. Correct answer is option B. Describe the proposed changes using deployment manager. Store them in cloud source repository. Now let's take a look at each of these options. Here option E is incorrect because while using deployment manager templates to describe the proposed changes is a good practice, but storing them in a cloud storage bucket is not the recommended approach. So cloud storage is primarily designed for storing and accessing files and objects, but it is not the ideal solution for managing infrastructure configuration files like deployment manager templates. So this option is not the correct one. Let's take a look at option C. Apply the changes in a development environment. Save the output of the gcloud instances list command in a shared storage bucket. Option C is incorrect because applying changes before the review is not the best practice. Now let's take a look at option D. Apply the changes in a development environment. Save the output of the gcloud instances list command in cloud source repository. Here also, applying changes before the review is not a best practice. So in both of this option C and D, they have mentioned apply the changes in a development environment and then save the output. But in the question, they have stated that you need to get the proposed changes reviewed by your team. So you need to review the changes before it is applied, right? So in that case, option C and D does not fall under this. So option C and D are obviously incorrect. So the obvious correct answer will be option B. Describe the proposed changes using deployment manager, then store them in cloud source repositories. So option B is correct because it aligns with the Google's recommended best practices for managing the infrastructure changes. Here, by making use of deployment manager templates, we can define and describe the infrastructure changes in a declarative manner. And by storing these templates in a cloud source repository also helps with the collaboration among the team members, and it is a centralized location for managing the changes. So cloud source repositories are specifically designed for hosting and versioning source code, while deployment manager templates are configuration files that define the desired state of the infrastructure. So storing them in a source code repository allows you to track the changes, manage different versions, and collaborate with the rest of the team effectively. So the correct option is option B. Now let's proceed with question 8. You work as a data scientist in an e-commerce shoe selling company. Your website uses Cloud Spanner as its database backend to keep current state information about users. All events triggered by the users are logged in Cloud Bigtable. The Cloud Spanner data is exported every day to cloud storage for backup purposes. Your data science team is training an ML model on the user data, and they need to join data from Cloud Spanner and Bigtable together. How can you fulfill this requirement as efficiently as possible? So these are the options available. The correct answer for this question is option D. Create two separate BigQuery external tables on cloud storage and cloud Bigtable. Join these tables through user fields using the BigQuery console and apply appropriate filters. Now let's take a look at each of the other options. Option A, copy data from cloud storage and cloud Bigtable for specific users using a data flow job. Here option A is incorrect because this requires us to create a data flow job, and creating a data flow job requires significant effort. Whereas in the question they have asked us, we have to fulfill this requirement as efficiently as possible. Now let's move ahead with the option B. Create a data flow job that copies data from Cloud Bigtable and Cloud Spanner for specific users. So here also we need to create a data flow job, and it also requires some effort. So now let's take a look at option C. Write a Spark job that runs on a Dataproc cluster to extract data from Cloud Bigtable and cloud storage for specific users. This option is incorrect because using Dataproc and Spark can require significant effort and time. So now let's take a look at option D. Create two separate BigQuery external tables on Cloud Storage and Cloud Bigtable. 2. Join these tables through user fields using the BigQuery console and apply appropriate filters. So this option is correct because BigQuery supports analytics on data through external tables from cloud storage and Bigtable. And for this scenario, this is the perfect solution. All these option A, B, C, it requires a significant amount of time and effort, whereas option D is the perfect solution for this scenario. Now let's move ahead with the question 9. You work in the business intelligence engineering department in your company. You are collaborating with another team at your organization to build a business intelligence dashboard for the directors of the company. The other team owns the data, which they use to generate reports on a daily basis using a cron job on a VM in a corp data analysis project. Your team is working on the front end of the dashboard and they need a copy of the daily exports in the bucket corp total analysis storage in the corp total analysis project. You are asked to configure access for the daily exports from the VM to be made available in the bucket corp total analysis storage in as few steps as possible using Google's recommended practices. What should you do? These are the options available. The correct answer is option B. Assign storage object creator to the VM service account on corp total analysis storage. Now let's take a look at each of this option and understand why this option B is correct. Option A, move both projects under the same folder. Here option A is incorrect because moving the two objects requires migration efforts and it may not be possible. Let's take a look at option C. Create a shared VPC network between both projects. Assign the storage object creator role to the VM service account on corp data analysis. Here, creating a VPC network between the two projects will not do anything as cloud storage is not part of the VPC. So option C is incorrect. Option D. Make the bucket corp total analysis storage public and create a folder with a pseudo randomized suffix name. Share the folder with the IoT team. So in this option, it suggests that to make the bucket public. So making the bucket public is a security risk and it should not be done. So the correct answer will be option B. Assign storage object creator to the VM service account on corp total analysis storage. With this, we are granting service account access to create objects in the other project, and this is the fastest and recommended way to achieve this scenario. So option B is the correct one. Now let's move ahead with the question 10. You work at a large logistics and shipment company. The shipment tracking application is hosted on Compute Engine VMs in the US Central 1A zone. You want to make sure that the app does not go down in case of a zonal failure on GCP. How should you do it with minimum cost? So these are the options available. Here option A is the correct one. Create compute engine resource in US Central 1B. Set up a load balancer to balance a load across both US Central 1A and US Central 1B. So now let's take a look at other options which are incorrect. Let's take a look at option B. Create a managed instance group with a zone specified as US Central 1A. Configure health check with a short health interval. So in option B, we are creating a managed instance group in the zone US Central and we are configuring the health check. But this health check will not be helpful if the zone goes down. So here in the question, we have to ensure that the app does not go down in case of a zonal failure. But if the zone goes down, configuring the health check will not be of much use. So option B is not the correct. Moving to option C, create an HTTP load balancer. Direct traffic to your VMs using one or more global forwarding rules. Here also, creating a load balancer will not ensure that the app does not go down when there is a zonal failure. And creating a load balancer will not automatically provide high availability. So option C is incorrect. Now let's take a look at option D. Backup your application regularly. Create a cloud monitoring alert to be notified in case your application becomes unavailable. Restore from backups when you receive a notification. Here, backing up is a good practice, but it does not help with a zonal failure. And creating a cloud monitoring alert will send us a notification when the application goes down. So backing up the application regularly and creating a cloud monitoring alert will not ensure that the application does not go down during the zonal failure. So option D is incorrect. So options B, C and D are incorrect. Let's take a look at option A. Create compute engine resources in US Central 1B. Set up a load balancer to balance the load across both US Central 1A and US Central 1B. So here option A is correct because we are setting up a load balancer to balance the load across both US Central 1A and Central 1B. So we have multi zones here available. So if one of the zones goes down, the application will be available in another zone. So in order to remediate the problem of a single point of failure, we have to replicate VMs within the multiple zones. So by having multiple zones available, we can ensure that the application does not go down in case of a zonal failure. So option A is the correct one. Now let's move ahead with the question 11. There are thousands of employees in your company working from all over the globe. All users in your organization have an Active Directory account. Your organization wants to control and manage all of the Google's and Google Cloud Platform accounts of employees through Active Directory. What should you do? So these are the options, and the correct answer is option A. Synchronize users into cloud identity using Google Cloud Directory Sync. Now let's take a look at other options which are incorrect. Now let's take a look at option B. Write a script using Cloud Identity APIs to synchronize users to Cloud Identity. Option B is incorrect because we don't have to write any custom scripts because we already have some ready-made solution which already exists. We can make use of that instead of writing any custom scripts. Now let's move ahead with the option C. Upload a CSV containing an export of all Active Directory users in Google Admin Console. So exporting CSV of all Active Directory users is a time consuming and error prone process. So option C is not correct. Now let's move ahead with the option D. Ask each employee to sign up for a Google account and require them to use their company email address and password. This option is incorrect because asking each employee to create their own account does not provide central management of identities. So this option is not the correct one. Whereas moving with option A, synchronize users into cloud identity using Google Cloud Directory Sync. This is the correct answer to our question. Here, Google Cloud Directory Sync enables administrators to synchronize users, groups, and other data from an Active Directory or the LDAP service to their Google Cloud domain directory. So this is the best option which we can utilize for this scenario. Now let's move ahead with the question 12. Every night at 1 a.m., a batch job runs on your GCP project that uses a large number of VMs. The batch job is fault tolerant and it can still run properly if some of the VMs gets destroyed. Your goal is to reduce the cost of this job. What should you do? So these are the options available. And the correct answer is option A. Run the batch job in a simulation of maintenance events. If the test succeeds, use preemptible N1 standard VMs for future jobs. Now, let's take a look at other options which are incorrect and understand why option A is correct. Let's take a look at option B. Run the batch job in a simulation of maintenance events. If the test succeeds, use N1 standard VMs for future jobs. This option is incorrect because in the question they have mentioned that your goal is to reduce the cost of this job. But making use of N1 standard VMs do not save cost as much as preemptible VMs. So option B is incorrect. Now let's check option C. Run the batch job in a managed instance group. If the test succeeds, use N1 standard VMs in the managed instance group for future jobs. Here, managed instance group will not provide cost savings as much as preemptible VMs. So this option is incorrect. Now let's take a look at option D. Run the batch job using N1 standard VMs instead of N2. If the test succeeds, use N1 standard VMs for future jobs. Here also, making use of N1 standard VMs will not save cost as much as preemptible VMs. Now let's take a look at option A. Run the batch job in a simulation of maintenance events. If the test succeeds, use preemptible N1 standard VMs for future jobs. Option A is correct because we will be making use of preemptible VMs, and these preemptible VMs can provide up to 80% discount over normal VMs if the workloads are fault tolerant. So our goal is to reduce the cost of this job. So for this scenario, option A is the correct one. Let's move it with the question 13. You are part of the data engineering team at an e-commerce company. You are managing the BigQuery dataset that contains user activity data. Another team has requested access to the BigQuery dataset, but you need to make sure that they do not accidentally delete any datasets. What are some of the recommended best practices to grant access? So these are the options available, and the correct answer is option D. Create a custom role by removing delete permissions, add users to the group, then add the group to the custom role. Now let's take a look at other options which are incorrect. Option A, provide users with roles BigQuery user role only instead of roles BigQuery data owner. Option A is incorrect because it allows the creation of new data sets within the project. Now let's take a look at option B. Provide users with roles BigQuery data editor role only instead of roles BigQuery data owner. This option is incorrect because the data editor role will allow the users to update or even delete the data. So in our question, we have to ensure that we don't accidentally delete any data sets. So this option is incorrect. Now let's take a look at option C. Create a custom role by removing delete permission. Add users to that role only. So here it states that add users to that role only. So it is not a best practice to grant roles to users directly. As per Google's best practice, we have to ensure that we grant roles to groups and not users. So option C is incorrect. Now let's take a look at option D. Create a custom role by removing delete permissions, add users to the group, then add the groups to the custom role. This is the best solution for this question because here creating a custom role with no delete permission will ensure that users will not be able to accidentally delete any data sets, and granting the role to groups is considered the best practice as per Google's recommendation. So option D is correct. Now let's move ahead with the question 14. You are building a stock trading app using Compute Engine and Cloud SQL. The app is deployed in a development environment and you are planning to release it to the general public soon. You need to create a production environment for the release. Your security team has given a list of recommendations to be implemented for the production environment. One of the non-negotiable requirements is that network routes should not exist between the two environments. What is the Google's recommended way of fulfilling this requirement? So these are the options available, and the correct answer is option A. Create a new GCP project, enable the compute engine and cloud SQL APIs, replicate the development environment setup in the new project. Now let's take a look at each of these options. Option B. Create a new subnet in the existing VPC and name it production. Create a new Cloud SQL instance for production in the same project. Deploy the application using those resources. This is not the best practice as it will allow communication between the two environments. Let's take a look at option C. Create a new project. Update your existing VPC to be a shared VPC. Share that VPC with your new project and replicate the development environment setup in that new project in the shared VPC. So this option is wrong. Updating the existing VPC to be a shared VPC and sharing that VPC with a new project. So this is not the best practice. The main goal of VPC is a virtual private cloud. We have to isolate the environments, but creating a shared VPC will allow entities in both the VPCs to communicate with each other as if they were in the same VPC. So this is not the best practice. So option C is incorrect. Now let's take a look at option D. Request your security team to grant you the project editor role in one of the production projects used by another team. Replicate the development environment setup in that project. The replicating the setup in the project is not the best practice. So option D is incorrect. Let's take a look at option A. Create a new GCP project. Enable the compute engine and cloud SQL APIs. Replicate the development environment setup in the new project. Here we are ensuring that the development and production environment is separate. It is a best practice, and in this way we isolate the environments So option A is correct for this scenario. Now let's proceed with the question 15. You're building an API using Python. The API internally uses several Google Cloud services using application default credentials. You have tested the API locally and it works correctly. As a next step, you want to deploy the API on a compute engine instance. How can you set up authentication using Google recommended practices and minimal changes? So these are the options available. And the correct answer is option A. Provide necessary IAM permissions for Google services to the compute engine VM's service account. Let's take a look at other options, why they are not correct. Option B. Create a new service account and provide it with appropriate IAM permissions. Configure the application to use this account. Creating new service account is not required for this scenario. Let's take a look at option C. Create a config file containing the service account credentials. Deploy this config file with your application. Option C suggests to create a config file with the service account credentials. So this is not safe because storing credentials in a config file is not safe and it can be exposed to all the users. So this should be avoided. So option C is incorrect. Let's take a look at option D. Create a config file containing the user account credentials. Deploy this config file with your application. Even this option also suggests to create a config file with the user account credentials. So this will expose the credentials, which is not a best practice. So this option is also not correct. So let's take a look at option A. Provide necessary IAM permissions for Google services to the compute engine VM's service account. So this is the best solution for this scenario. With this, we can attach service accounts to resources for many different Google Cloud services like Compute Engine, Google Kubernetes Engine, App Engine, Cloud Run, and Cloud Functions. So this strategy is recommended because it is more convenient and secure than manually passing credentials in a config file. So option A is the best solution for this scenario. Now let's move ahead with the question 16. You work at a $1 billion RPG game development company. You're running your gaming server on JKE. JKE is nothing but Google Kubernetes Engine on multiple pods running on 4 or N1 standard 2 nodes on a JKE cluster. Additional pods need to be deployed on the same cluster requiring an N2 IMM16 type of node. Your app is live in production and cannot afford downtime. What should you do? So these are the options available. And the correct answer is option B. Create a new node pool with N2 IMM16 machine type. Deploy the new pods. Now let's take a look at each of these options. Option A. Run gcloud container clusters upgrade before deploying the new services. Since the need here is we need to deploy new additional pods on the same cluster but with the different machine types. Option A suggests to upgrade the clusters. And the need is to create a new node pool for the new pods as they require different type of instances. So option A is not correct because we are deploying new pods with the different machine types. So option A is incorrect. Let's move ahead with the option C. Create a new cluster with N2 IMM16 nodes. Delete the old cluster and redeploy the pods in the new cluster. We don't have to create a new cluster here, as in the question it states that additional pod needs to be deployed on the same cluster. So you have to ensure that the pods gets deployed on the same cluster but with different node pool. So option C is incorrect. So let's proceed with the option D. Create a new cluster with both N1 standard 2 and N2 IMM16 nodes. Delete the old cluster and redeploy the pods. There is no need to create a new cluster. So again in option D, it suggests to create a new cluster. This is not required because the ask is different. So we have to ensure that we use the same cluster and deploy the pods with the different machine types. So let's take a look at option B. Create a new node pool with N2 IMM16 machine type. Deploy the new pods. So this option is correct because we can add new types of instances to the JKE cluster by adding node pools and this will not cause any downtime to the existing cluster. So option B is correct for this scenario. Now let's proceed with the question 17. You are using Ubuntu for developing HRMS software on GCP. You installed the Google Cloud SDK using the Google Cloud Ubuntu package repository. Your application uses Cloud Data Store as its database. How can you test this app locally without deploying it to GCP? So these are the options available. And the correct answer is install the Google Cloud SDK Data Store Emulator component using the apt-get install command. Now let's take a look at each of these options. Let's take a look at option A. Use gcloud data store export to export cloud data store data. This is not correct because exporting the data from the data store does not enable you to test the data store locally. Here the ask is to test the app locally without deploying it. But the option A does not fit the solution. So let's move it with the option B. Use gcloud data store indexes create to create a cloud data store index. And this option is incorrect because creating indexes does not enable you to test data store locally. Let's check the option D. Install the cloud data store emulator component using the gcloud components install command. Here the data store emulator is installed using apt and not gcloud. So the command itself is wrong. So this is not correct. So let's check the option C. Install the Google Cloud SDK data store emulator component using the apt-get install command. So this option is correct because the data store emulator is installed using apt and not gcloud. So when we install this emulator, we can test our application locally without deploying it to the GCP. So the correct option is option C. Now let's proceed with question 18. You are owner of a fast growing financial services startup. You have recently hired a person to manage all service accounts for Google Cloud projects. What is the minimum permission you should grant this person to allow him to perform his duties? So these are the options available. And the correct answer is option D. Provide the user with roles IAM service account admin role. So now let's take a look at each of these options and understand why option D is correct. Let's take a look at option A. Provide the user with roles IAM role admin role. This option is incorrect because here we are providing role admin. So this role admin is a much broader role which is not required in this scenario. And this role admin role is not necessary for managing service accounts in Google Cloud projects. This role will grant full control over IAM policies and bindings, including the ability to create, update, and delete roles. And this role is not specific to managing service accounts. Now let's look into option B. Provide the user with roles IAM security admin role. This role does not allow the management of service accounts. By providing IAM security admin role, this role grants permissions to view and manage IAM policies, but it does not provide the necessary permissions for managing the service account. Now let's take a look at option C. Provide the user with roles IAM service account user role. Even this option is incorrect because service account user role will not allow the creation and management of service account. This role only provides the user with the ability to use service accounts, but it does not grant permissions to manage or administer the service accounts. This is a more limited role. Now let's look into option D. Provide the user with roles IAM service account admin role. This option is correct. This role grants the user the ability to create, update, and delete service accounts as well as manage IAM policies for the service accounts. So it is specifically designed for managing the service accounts within Google Cloud. So this option D is the correct one for this scenario. Now let's proceed with question 19. You work in an app development startup as a cloud engineer. Your company extensively uses Kubernetes on JKE. Several applications are deployed on separate VPC native Google Kubernetes Engine clusters in the same subnet. There are no more IPs available in the subnet. How can you ensure that the clusters can grow in nodes when needed? These are the options available. And the correct answer is option D. Expand the CIDR range of the relevant subnet for the cluster. Now let's take a look at each of these options and understand why option D is correct. Option A. Create a new subnet in the same region as the subnet being used. For this scenario, creating a new subnet is not required. So this option is not correct. So let's check the option B. Add an alias IP range to the subnet used by the JKE clusters. Here adding an alias IP range does not expand the subnet. So option B is not correct. Let's move it with the option C. Create a new VPC and set up VPC peering with the existing VPC. Since we already have a VPC, there is no need to create a new VPC. So this is a time consuming process and it is not required for this scenario. So option C is not the correct answer. Let's take a look at option D. Expand the CIDR range of the relevant subnet for the cluster. So this is possible because every subnet must have a primary IP address range, and we can expand the primary IP address range at any time, even when Google Cloud resources use the subnet. So option D is correct. So now let's move ahead with a question 20. Your firm generates hundreds of GB of user data per week. You are planning to store backup of your on-premise application data to cloud storage. The backup data is expected to be accessed once a quarter in case of a disaster. Which storage option is most cost efficient for this use case? So these are the options. Correct answer is option A, cold line storage. Now let's take a look at each of these options and understand why this option A is correct. Option B, nearline storage. Nearline storage is a low cost, highly durable storage service for storing infrequently accessed data. So, this nearline storage is ideal for data you plan to read or modify on average once per month or less. So, if you want to access your data on average once per month, you can make use of nearline storage. But in this scenario, the data is expected to be accessed once a quarter in case of a disaster. So, option B is not the correct one. Let's take a look at option C, regional storage. Here, there is no mention of regional or multi regional data availability. So, this option is not correct. Option D, multi regional storage. Even this option is not correct because nowhere in the question they have specified about this regional or multi regional data availability. So, let's take a look at option A, cold line storage. So, cold line storage is ideal for data you plan to read or modify at most once a quarter. So, cold line is the most suitable storage class for this use case. So, this is the end of this video. I'll be posting another set of questions in module 2. So, please stay tuned to the channel. And if you're new to my channel, please like and subscribe to my channel and stay up to date with the latest content on this channel. Thank you all for watching. We'll see you in the next video.